Hello, this is David Bishai. I'm here to give a lecture on income distribution, and poverty. Here's the outline. First, we'll offer a brief description about life expectancy and age pyramids, and then go over national income, the GDP, shortcomings of measures like the GDP. We'll cover income distribution, talk about poverty, and then we'll have a summary. First off is age pyramids. An age pyramid has a vertical axis, which are age groups, usually 5-year age groups. And you can see here Kenya has an age going from 0 to 100 plus. Males are on the left in blue, females are on the right in pink, and each bar gives us the percent of the total population at each age. So for instance here I see that there are 6% of the population aged between 5 and 9. And 6.1% aged between 10 and 14, and so on. We see here in China, age pyramid looks a lot different. And that is a representation of population aging, which I'm about to discuss. In general, countries with high fertility have lots of children, and they have pyramidal shapes, like a pyramid. And populations that are aging have rectangular-ish shapes, like Hong Kong does. Age pyramids turn into rectangles, and the process whereby they do this is fertility decline. If we take a pyramidal age pyramid on the left with lots of young children going into middle and then old age, if we were to simply cut that population's fertility between 1950 and 1980, then they wouldn't have as many babies in 1980, and you can see that the age pyramid has fewer babies in 1980. But those young people are now 30 years older, and there's this bulging group of middle-aged people. Then the middle-aged people in 1950 have now become old people, and so we see a bulging rectangle, which has really good features for the economy because these middle-aged people are working very hard and there's not as many people to support. However, another 30 years go by and there's aging, and those middle bulge turn into old people, and now you have an inversion where there's a high old age dependency ratio. Number one feature is that the most important reason a population goes through aging is not because they get healthier, it's because they drop fertility 60 years ago. So the things to note about age pyramids are, first, there is a slope of the age pyramid that is driven by changes in fertility across periods. It's also driven slightly by changes in mortality across age. The width of the base of the pyramid is determined by fertility. And aging occurs mostly because of fertility decline 60 years ago. The health of a population determines whether or not that top part of the pyramid is aging. Next thing to talk about is life tables. The basic ingredient of a life table and of a life expectancy at birth measurement is shown in this graph, which is a graph of age-specific mortality rates. That was driving the shape of the age pyramid we just showed you. Here is the population of London in 1850 in these solid lines. And we see females in the diamonds and males in the squares. And we see that in 1850 we had really similar life expectancies for females and males in London. We also had an anomaly where the death rate of 1-year-olds was higher than the death rate of 0-year-olds. This almost never happens. We'll talk about in the next lecture why London was having a worsening of survival after the first year of life. The point of this article was to show that, yes, in the 50-year span, life expectancy fell for both, mortality fell for both females and males, and we see that the solid lines all shifted downwards. We see that the females had a larger gain in life expectancy, and their shift in the mortality reduction was higher. These blue callouts are just the way we talk about age-specific mortalities. Demographers call them NQXs, where N is how many years we're going to have in the number of years of survival. These are 5-year age-specific mortalities because they go 20 to 24, 25 to 29, and so on. And so these are 5-year age-specific mortalities. And this one happens to be the one for the 20-year-olds, so we call it 5Q20. This one happens to be the one for the 70-year-old, so we call it 5Q70. What a demographer does is looks at a population, looks at how many people die at every age, and calculates the risk of dying at every age. We want a quick way to talk about all of these numbers at once. Each curve for the boys and the girls has about 20 numbers in it. And how do we summarize them all at once? Well, we want to take a weighted average of these age-specific mortalities, these NQXs. And the way we weight them is we use these NQXs to say what a simulated age pyramid would look like for a group of 1,000 babies born at age 0 and then having to die according to this schedule of age-specific mortalities. And you could do this on any Excel spreadsheet. You could take 1,000 babies and you could survive them through an Excel chart by getting rid of that proportion at age 0, you'd get rid of that proportion at age 1, and so on down the life table. And then you would take a weighted average of these NQXs by the number of children that would be on every row of the life table. When we talk about life expectancy at birth, it's a weighted average of NQXs weighted by the age pyramid of a population that would be subjected to those NQXs. Now, there is no population that would actually have lived through all of these NQXs. They were measured in 1850, but 40 years later, it's not 1850 anymore. If you were born here in 1850, 50 years later, you'd be subjected to the 1901 age-specific mortality. So you wouldn't really feel the pressure of these NQXs. It's a simulation of what it would be like to live in a population where these were your death rates over time. But it does give us a way of summarizing with a single number what these age-specific mortalities would be. What you can see is that the high weights occur in an age pyramid that looks like this. So when you have an age pyramid with a large base, like the one on the left, the death rates of the young are going to count a lot. And when you have an age pyramid that looks like this, with a high number of old people, the age-specific mortalities of the old count a lot. So that's what I want to say about life expectancies and how they're calculated. They're weighted averages. The weights are basically what an age pyramid would look like. I want to move on to income distributions. Here's a simulated income distribution, and we want to talk about its average, and we summarize the average income distribution using GNP or GDP per capita. We talk about the width of the age distribution, how wide it is, using a Gini or a Robin Hood or a tile index. We want to talk about the size of this left tail using a poverty head count or poverty gap measure or a SEN index. So first off, national income. Just backing up for a second about the nature of life and spending. Life has good things like sunrises and people doing you a favor and eating ice cream. Life has bad things like loneliness and getting your teeth taken out. And so life has all of these blue box of things. We want to summarize how good life is, but we can't measure all of the good things in life. As economists, we can only measure this white box of the things that can be traded. But we can't even measure all of that. We can only measure the good and bad things that are traded for money. So this yellow box tries to accommodate all of the good and bad things in life, and it really can't. It's only the things that are traded for money. And this is called expenditure. When we give money to another person for something, we might be trading the money for a tooth extraction, but we've traded the money anyway, and the economist is going to count that in all of the national expenditure. In our reading and in our study, we want to know whether we're measuring growth or development. In human beings, we can measure the size of a human being and tell how tall a child is or how much it weighs. That growth of the child over time is something that gives moms and dads a lot of happiness. They do care about how big their children are, but they care even more about their children's capacity to realize the goals of human functioning, and that is development. So parents care not just about measures of size, but can my child tie their shoes? Can they jump rope? Can they know their alphabet? Those are markers of their ability to realize goals. Now, when we talk about economies, we can measure their size, how tall or fat they are, with expenditure measures, but we do care about a population's capacity to realize the goals of human functioning. So growth and development are tied together. If you're not growing, you're probably not able to realize goals. But how tall you are, how big you are, may not be the full measure of whether or not a population can realize goals of functioning. So let's start off with some definitions. First off is a balance equation. A country can only expend the income that it earns. So national expenditure, all of the money that goes out from consumers to producers is expenditure, and all of the money brought in by people earning those expenditures is the income. So a trade is I give money for a good and service, I am spending, the person giving me that good or service is earning income at that time. Both expenditure and income, they equal each other, but they are monetized. They have dollar amounts attached to them, so they are called monetized goods and services, and they have to be flowing from one hand to another. So the monetized goods and services that are flowing in the economy in 1 year is going to be our measure of GDP or GNP. I can break down the MGS or monetized goods and services into these 5 categories. Consumption is the MGS purchased by consumers who want to just enjoy something. I, for investment, is the monetized goods and services that I would transform into something that I'm going to hold on to into the future to make more goods and services, like a truck or a bulldozer. The government, G, is monetized goods and services purchased by the government to do whatever a government wants to do. The government might just want to consume things as a government. It needs to pay workers to take up the garbage or to go fight in a war. Whatever the government does with the money, it's the G part of the national income. Then there are the trade part of an income. There is exports, X, and we subtract the imports, M, from that last part of the GDP. So if we export exactly as much as we import, we have zero net trade adding to the GDP. And you can see how M could be very large and negative, subtracting a lot of the GDP. GDP and GNP both get tossed around. They're both the value of monetized flowing goods and services. The only difference is whose monetized flowing goods and services we count. The GDP says that what matters the most is the borders of a nation or population. We just want to know where was the money spent. So it doesn't matter whose citizens are spending the money. It could be all tourists spending the money. All we want to know is the money moved hands inside that place in geography. The GNP, what matters the most is what is the citizenship of the people trading the money. So the GNP is the value occurring among the citizens holding a particular nationality, no matter where they live. So for example, the country of Qatar is mostly expats. More than 80% of their people are not citizens. So they have a very large GDP inside their country. There's a lot of money moving, but it's not moving between the citizens. So it has a smaller GNP. In Lebanon, the citizens are mostly living abroad. So inside the nation geography of Lebanon, they have a small GDP, but a large GNP. That's the only difference. In health, because we usually have health statistics from a geography, health economists want to know the GDP, how much money is moving in a place. However, very often there are people who are concerned with what is the well-being of the citizens of a country no matter where they are, and they would want to follow the GNP. Income is not the same as wealth. Income is the flowing goods and services. When we get our money every year, we put some in the savings bank and we put others in our mouths and buy things to consume, and those are called flows. But after we put savings in the savings account or we buy capital, we would be increasing our stock of wealth. If we buy property, if we buy a bulldozer or a truck, that might decrease because of depreciation. It just is physically becoming damaged over time, and that depreciates it. I could also decrease my wealth by dis-saving, taking money out of my savings account or selling a piece of my land in order to turn that wealth into current income. So wealth is harder to measure. It's a long, long list of the things that we might own. There are also in between items called consumer durables. These are things that we buy them because we want to use them right now, but they last many years. So that's in between a stock and a flow, like a television set. Conceptually, we think we are buying services from our consumer durables. So if I buy a TV set, I have bought a piece of capital, and that might be my wealth, but then I am renting my entertainment, and the entertainment I get from my television is a flow. We have to talk about inflation. So the word real means we've adjusted GDP for inflation, and the word nominal means we have not adjusted the GDP floor for inflation. The reason to adjust is to make sure we are keeping track of the cost of living. So if a worker's wages rise as fast as their expenses, then they are no better off. And we want the GDP to have something to say about the real value of resources. And if there's just lots of inflation, it doesn't mean people are getting better off. So we want to keep score of how people are doing by adjusting for inflation. We use price indexes for this procedure. A price index is a product produced by economists where they take a basket of goods, a representative bundle of the things that people buy in that economy. So the government economist defines a representative bundle, and then they go and send professional shoppers out to ask what would it cost to buy that bundle every single year over time. So for example, the consumer price index in Hong Kong was 100 in the reference year of 1997. They defined a bundle, they went out to price it all around Hong Kong, and then 25 years later in 2022, they tried to shop for that same bundle and it was 40% higher. And so over that 25-year period, there was a 40% rate of inflation. So we can use the CPI to adjust the nominal GDP, what we would get if we just went and measured the monetized flowing goods and services in 2022 at its price on the sticker. We would go and take this GDP deflator or this price index and use that to adjust the nominal GDP into real GDP. So the way we adjust a GDP is to use a price index, and we would either use the Les Pairs price index, which is calculated as the value of an old bundle at today's prices divided by the value of an old bundle at the old prices. The Posh price index is different. It's the value of today's bundle at today's prices divided by the value of today's bundle at the old prices. That's not the point. That matters, and the reading might tell us why there's a difference between the Les Pairs and the Posh index. One is more heavily influenced by the price of old things, and one is more heavily weighted by the price of new things. So the Les Pairs overcounts items whose price has changed a lot more than their volume has changed, and the Posh index undercounts those items. So the way to use these indexes, whatever they are, is to pick a baseline year and set your price index equal to 1 in that baseline year. Then measure it in subsequent years, and you do this quick bit of mathematics. The real GDP relative to that baseline year, let's say 1997, is the nominal GDP divided by the index in this new year. So I would take my GDP in Hong Kong, measured in 2022, and I would divide it by 1.4, because remember the price index went from 100 to 140, and the index actually went up by 1.4. So that's how I would use the price index. Big question about GDP and value. The GDP, does it really measure what is good for society? No, it doesn't. There are many problems with it. It doesn't count good things that are not monetized. A good is something that people would want more of, and they would pay if they could have more of it. So there's many good things that can't be traded. It also has bad things that are monetized, things like tooth extractions and cancer. They cost money, and they're in the GDP. COVID really drove high the actual spending on health, and there were large contributions of COVID to economies, but they're also large subtractions because people didn't have great incomes. So there are valuable goods that are not monetized. Quasi-monetized things are traded, but they're not in the official statistics. Trading cocaine, trading prostitution is monetized, but not really according to the statisticians, because people don't report this in their earnings statements. There are things that are mostly non-monetized, like home cooking and domestic chores. There are things that are never monetized, like clean air, personal liberty, or having peace in one's society. Then there are monetized things that are bads, crime and disease and pestilence and garbage. They all cost money, and GDP counts them positively. So we are disappointed with GDP representing that. One of the largest problems with GDP is it has nothing to say about income distribution and who is poor and who isn't poor. So if we are going to look at GDP, we are going to need to do something to represent the scale of poverty. There's also bias in cross-country comparisons because northern developed countries spend a lot of their GDP on heating and insulation and warm coats, and they don't enjoy life because they have to wear a big down vest every day. Developed countries also waste a lot of their GDP because they have smaller families, smaller people living in their houses compared to countries in Africa and South Asia where they save a lot of money by living together, 5 or 6 or even 10 or 20 living in a single home. We have a lot to say about exchange rates also being biased by goods that are traded internationally, and the PPP is a way of trying to adjust for that bias in cross-country comparison. PPP stands for Purchasing Power Parity. It was developed by Summers and Heston of the University of Pennsylvania. If you think about a Big Mac index, what it would cost to buy a Big Mac in every country, it's going to be a lot similar to the PPP. The basic idea is we want a unit of currency that can buy the exact same bundle of things in any country. And the journal The Economist thinks that a Big Mac requires a lot of labor, it requires bread and lettuce and beef, and it might be a representative bundle. So we want to actually define a universally comparable bundle. And Summers and Heston did that, and they tried to make a universal bundle that's not actually a Big Mac. The Big Mac is not really good for some countries where there's a lot of vegetarians and people don't value it that much. We have to make that bundle really something representative. It's not easy because in India people eat mangoes, in America they eat apples. How do you get a representative fruit? They worked hard and they've made this PPP, and so throughout our comparisons we'll often use the PPP so we can measure apples to apples, literally, what is the value of that GDP in that country at that time. Now there are distortions that one can see if we compare the ratio of the PPP exchange rate to the currency exchange rate. For instance, in sub-Saharan Africa, that ratio is 0.29. So a dollar of PPP money can buy 3 times the amount of stuff as that dollar in a high-income country. In a high-income country, a dollar buys a dollar. The representative bundle in France, Germany, USA, and Hong Kong, it's pretty much the same bundle. In India, that ratio of PPP to the currency number is 0.18. So a dollar in India will buy you 5 times the amount of that representative global bundle. And when people travel to low-income countries, they often find that it's really a great place to buy representative bundle items, clothing and food and so on. There are also problems with the measurement, just simple errors and distortions in GDP. And economists have graded the quality of GDP measurement. They've given A's to about 18 countries, 34 countries get C's, about 39 countries get D pluses and D's. This is just this 27 to 30% error rate in what the economists think is coming back as the GDP. China's GDP is given an F rating by global economists because they think that whatever China is reporting as its GDP may be off by plus or minus 50% when we do international comparisons. We tend to believe that China is making the exact same error every single year. So whether it's inflating or deflating its GDP, it's probably doing the same thing over time, we think. So China may be growing reliably with our data. They might be overinflating their GDP in 2020, but then overinflating it by the same amount in 2021, and we can still detect the amount of growth. We want to do better. We want to get something better than the GDP. So we care about development, but we can barely measure growth. What do we want to do? We want to develop measures of development as opposed to growth, not just how big the economy is, but can they do things that they want to achieve. The physical quality of life measure is the unweighted average of infant mortality rate, the expectation of life at age 1, E1 stands for the expectation of life at age 1, or the adult literacy. These are kind of tightly correlated. After middle income range, after your GDP per capita is up above $10,000 to $15,000, all of these things tend to move together. So we're disappointed. What Sen has brought up is the Human Development Index, which is an unweighted average of longevity, education, and GDP. He has a way of adjusting longevity using this formula where you give it a base of 25 and a top of 85, and you say how far between 85 and 25 is longevity. He has a weighted average of education, which is 2/3 of the literacy rate and 33% of the gross enrollment rate of a country, and then he has an adjustment of the GDP. Now, Sen says that there is an equal weighting of longevity, education, and GDP. He doesn't give a reason for why all three of them should be weighted the same way. The Human Development Index has problems. The life expectancy at birth and schooling measures have been poor. Schooling is not comparable across countries because not all schools are equally good at teaching people. And the PPP per capita really gives a high fit for a high correlation between life expectancy and education. The Human Development Index does not include gender, so the UNDP, the United Nations Development Project, has a gender-weighted Human Development Index to try to fix this, and the HDI does not measure the distribution of income. I want to go over income distribution and how to measure that. We use the Gini coefficient to do that. What I've drawn here on this Lorenz curve is the cumulative income status by household between, I've ranked up all the households. This is the poorest 1% of houses. Up here at the far right is the richest 99% of households. And the Lorenz curve measures the cumulative proportion at every value. So here, let's look at this bottom rectangle. If I had a population that looked like this, where they were flat, 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 the bottom 99% of the population would all own zero money, and the richest 1% would own all the money. This would be the maximally most unequal population. If I had a population on the diagonal 45-degree curve, every time I moved 1% to the right, I would move upwards 1% of the cumulative GDP. When I move 2%, I've accounted for 2% of the GDP. When I moved up 50%, I've accounted for 50% of the GDP. So this is the line of perfect equality, where the GDP is equally owned by everybody in the population. So the Gini ratio is simply the area A divided by the total triangle A plus B. If your Gini coefficient is 1, then A plus B over A plus B is equal to 1, and you are actually living in this world where 99% of the population has zero money and 1% has all the money. And if your Gini is 0, because area A is 0, and you're 0 over A plus B, you're on this line of 45 degrees and you have perfect equality. So Ginis that are 1 are perfectly unequal. High Gini ratios are bad. 1, the number 1 looks like the letter I to me. So I remember Gini of 1 of inequality. A Gini of 1 is capital I, perfectly unequal. So when you see high Ginis, you know it's perfectly unequal. Hong Kong has a Gini of 0.51, and that's actually a very high Gini. We're on the top 20 Gini coefficients in Hong Kong with a 0.51. Countries can do well, they can get down to the 0.2s, sometimes into the 0.1s. There's no place that is a zero, but Ginis can be far lower than they are in Hong Kong. Another measure of income inequality is the Robin Hood Index, where we draw the Lorenz curve, but then we try to draw a red curve and we just measure how long is that red line between A and B. How far would we have to go to get to perfect equality from wherever we are. So the Gini can be interpreted as an average of all of the pairwise differences in the population. So when we take a population like Hong Kong, we're trying to average all 7.5 million Hong Kongers and say, what are all of the possible differences in their incomes averaged over 7.5 million people? The Robin Hood Index is proportional to the amount of money that would have to be redistributed in Hong Kong to achieve perfect equality. There are other equity indexes. There's an equity-weighted GDP, which is the GDP times 1 minus the Gini. You can use that as a welfare measure. There's also a tile index given by the formula in the textbook, also represented here, and that can be decomposed and mapped on a map of geography. So going over to poverty. When we measure poverty, we can measure poverty as process-based, where we just count the money, we count income, count expenditure, and can count the variance in expenditure. Or we can count poverty with outcome-based. We can assess material needs, how stunted are the children, meaning lack of growth, how short are they. We can ask how much of the household's budget is spent on food, how literate they are, whether they have access to schools, and just measure these capabilities of a population. We can also measure income using tax data, using a survey like the World Bank's Living Standards Measurement Survey, where they go house to house, they knock on doors, they go into this 2 to 4 hour long interview, measuring all of the assets, all of the remittances that are sent from family members back home, income and expenditures. And in theory, as I said, income equals expenditures, but usually when they're reporting on these surveys, the expenditures are measured more precisely. Headcount poverty is something that we often use, and the World Bank has offered the $1 a day headcount poverty measure, which is just about enough to buy 2,250 calories and nothing else. So if you buy clothes or school books, then you're going to lose weight, you'll start to starve. The $2 a day is calories plus some participation in society. This is measured based on income. It's adjusted for purchasing power parity. It also makes this really strong assumption that two people anywhere in the world with $1 a day poverty will have the same measured poverty. It means that everybody below the cutoff is equal, and that's not true. If you're living on 50 cents a day, your life is drastically different from 90 to 95 cents a day. It's not fair to say that all headcount poverty is the same. So there are measurement problems with poverty. We do need a nationally representative household survey with people actually showing up and representing themselves at the bottom of an income quintile. It's hard to do that. It's also hard to get a lot of people representing space. Imagine if we'd surveyed 10,000 people from 20 different provinces. There'd be 500 per province. There would be only 100 in the poorest quintile in each province. And we really can't estimate the number of poor in a small place based on a sample that's only 500 in representing a large population. You know, what if the poor are heavily concentrated at only 2 out of 10 provinces? What if we don't have representative enrollment? So it's really time to be heroic in making assumptions when we use headcount poverty, but what else are we going to do? Here's a map of the World Bank's version of the population of the world and where the poor are, and the headcount poverty regions are really concentrated in sub-Saharan Africa, which has 60 to 80% in these areas living with $1 a day poverty. In the orange, we see areas here, also in sub-Saharan Africa, living with poverty. And in the New World, we have both Guatemala and Haiti living with 40 to 59% headcount poverty. The yellow regions, India and Mongolia and Laos, are also substantially poor with 20 to 40% headcount poverty. So let's talk about a pragmatic approach. Amartya Sen has asked us to think again, and he has asked us to count the capabilities of people to do things. He says a capability is the freedom of a person to achieve a state of being, of doing, and functioning. And the freedom to attain these is really the measurement of development. So he says development is freedom, and whether or not you attain things is really up to you, but if society has given you capabilities, then it's done its part. Amartya Sen says the four principal capabilities that matter are being adequately nourished, avoiding premature mortality, appearing in public without shame, and being free. It's really hard to actually operationalize this. It's hard to count the capability to achieve something, but we can count the ability of people to have something. If they have it, we know that they could achieve it. So we can count stunting, which is a measure of being adequately nourished. We can count literacy, healthcare access, and political participation. So we're working hard to try to operationalize this pragmatic approach. So in summary, we want to think about measures of society's well-being that are reliable and replicatable and feasible. And it's a work in progress. And perhaps in our careers, we'll see more and more of that progress. Thank you very much for listening to this lecture. I hope to follow up with you in the future.